This video is a continuation of the Newton's laws exam questions. We talked about this cart being pulled in this manner shown in the picture. Question 3 is going to now take the cart and we're going to try to do a physics problem where the acceleration is 5 meters per second squared. So in this case what we have to do is we have to say that okay, now what I'm going to do is I'm going to give it the green light to accelerate this direction. And my acceleration is going to be equal to 5 meters per second squared. Now if we look at the other question, or the other part of the question, everything was balanced and so there's no acceleration. So the opposite of that is we're going to now kick it out of balance. So I can start off with really everything the same on my force diagram. And if everything is the same on this force diagram, it wouldn't accelerate. So what do I have to do? I'm going to take this one right here and I am actually going to have to increase it so that it is going to accelerate. So now you can see that it's out of balance. So is the force in this side 500 newtons? No. This force cannot be 500 newtons. So the question is, well, can we figure out what that force is? So we have to go up and we have to say, okay, what is our equation? And so this is a real good equation to use because it gives us a real good visual of how this works. So if we put this right here, we can say that the acceleration is going to be the net force divided by the mass. And so in following this equation, this is going to be 5. I'm going to use a different color here, red following it. So this is going to be 5. Is acceleration, and the net force is actually going to be, in this case, the net force is going to be the applied force plus the friction. That's the net force. These two forces will cancel each other out and become 0. We could add those if you wanted to, but they're not doing anything. So so FA is what we want to find, so I'm going to leave FA in the equation, and I know the force of friction is a negative 500, so I'm going to write that as a negative 500. That's that. And then the mass we said was 1,000 kilograms. So I can put 1,000 over here. Now solving this mathematically, I'm going to multiply each side by 1,000. This will cancel. And I get 5,000 is equal to FA, basically minus 500. I add 500 to each side to get rid of this, and I get 5,500 newtons is equal to the applied force. Now if you put that back into this original equation, what you're saying is that the acceleration of 5 meters per second is going to be 5,500 minus the friction of 500 divided by the mass of 1,000. And does this work? Well, is 5 equal to 5,000 over 1,000? So the ratio is perfect. These cancel out, and I get 5 is equal to 5 over 1. So yes, that works. This should be, I'll go back to green here, this should be a push of 5,500 newtons. Total, the sum of the forces to the right would be 5,500 minus a negative 500, or excuse me, minus 500 or plus a negative. So the last thing is Newton's third law, and Newton's third law with respect to this rocket. Newton's third law says that for every force there's an equal but opposite force. In the case of rocket, it doesn't push against the air in the atmosphere like an airplane does. A rocket explodes gases out of the nozzle with incredible force. That's called the action. And the gases then push back against the rocket and propel it forward. That's reaction. So rocket against gas, gas against rocket. Action, reaction. Rockets don't need an atmosphere to push against, but once they run a propellant, they're no longer able to create a backwards force to accelerate them forward. An airplane pushes the air in front of them, back behind them, and causing the action and reaction with the atmosphere. Rocket carries the propellant on board. Newton's third law.